Okay team, this is my first video to try and explain things to you when you're at home that you can then come back and ask questions in the classroom. So for this first one here, we're going to be talking about the difference between conduction, convection and radiation. Now it's important that we can distinguish the differences between the three, especially as you go on to year 9s and 10, when it gets really important that you can understand the difference. And that's what we're going to explain here. So if you're watching here, the video will only go for about 4 or 5 minutes. So make sure that you take some notes and some questions that you might want to ask me in class when we go through the actual questions. So the first one was conduction. Now the main thing to know about conduction is that heat is transferred through an object, through a solid in this case. Now how heat works is heat, temperature, it's vibrating particles. So in the example up here with the saucepan is the metal, the molecules are actually vibrating, and the hotter they get, the more they vibrate. As they vibrate, they can pass on their heat energy, their thermal energy, through the molecules all the way up to a cooler substance. So if it's really hot down the bottom, the heat wants to pass it along all the way until it gets a nice even temperature. So that passing of the heat through a substance, through the vibrating molecules, that is conduction. So the main thing to realize there is that conduction is passing heat through a solid. Now we have some objects which are really good conductors, like metal, and some which are really poor conductors, like wood. And from that we can design our utensils in a way where we're not going to burn ourselves. So for example, this guy who's about to grab this handle, which is metal, it would make sense if we had something on the top there which was a poor conductor of heat, so he wouldn't burn himself. Then we have convection. Now the big difference about convection is that convection occurs in gases and liquids. Now what's cool about convection is that it happens in a cycle, and it creates those currents like we saw in those thermal gliders. Now the best way I can describe this to you is through this example just across in the kettle. Now the kettle is under the fire here, or the pot, which is warming up, heating up the water down the bottom. Now as we know, hot water is less dense than cold water. So what do you think is going to happen with the water up here? Yeah, it's going to sink down to the bottom, pushing the hotter water up. That means that now we have cold water to the bottom. So now this cold water wants to warm up. As the cold water warms up and it gets more hot than the water up the top here, then that water gets pushed down, and so on. So it's a constant cycle of the water warming up and then the colder water falling back down. And that's where it creates this cycle of warming up and the less hot water dropping down to then get warmed up. And that's like how our air conditioners work at home. The hot air gets taken in, and then the cold air gets pushed out, and it cycles around the room. That's why often you can feel a draft, a bit of a wind, throughout the room when the air conditioner is on, because of how the air wants to move dependent on the temperature. So convection occurs in gases and liquids. And then the last one, radiation. Now the biggest difference between radiation is it doesn't need a matter to pass through. It's actually those electromagnetic waves. So in the example here, this person has their hand over the fire, and they don't actually have to touch the fire. They don't have to touch an object, but the heat radiates through and actually still warms up the hands. Okay, now this is something that you can always feel. We can even feel it on ourselves. Like when you've got a temperature in your forehead, you could not even touch your forehead, but you can put your hand near and you can feel the heat radiating off of you. That's because we still radiate heat. And the easy example is a fry pan. When it starts to get hot, you don't have to touch it to know that it's hot. You can put your hands just over a little bit and you can feel the heat radiating off. Now, some objects radiate heat better than others, and that's important to know when you're an engineer and you're designing different objects. So I hope this was helpful. If you have any questions, we can ask this at class, and I'm looking forward to seeing you. Bye, team.